Hello, thank you very much, Marie-Alex, and everybody, welcome to this webinar on artificial intelligence beyond the hype that we have organized with our new educational partner, Cognitir. As you well know, CFA Society France is committed to providing our members and candidates with the best possible education and professional development. Currently, the most sought-after skills for finance professionals and students are ESG and technology. In March last year, we partnered with CFA UK to offer the certificate in ESG investing. And now we are pleased to partner with Cognitir to offer training on one of the most sought after tech skills, which is artificial intelligence. Or is it data science? Or is it machine learning? Or Python programming? Well, if you don't know the difference between all of these, no worries. You're at the good place. David will tell you all about it in his presentation. By virtue of this partnership, all candidates and members of CFA Society France have 20% discount on all live instructor-led courses, but also on their virtual on-demand training. You will find all the details on the learning section of our website, and we will also share the link in the chat. And just to wrap it all up, we would like to share with you why we partnered with Cognitir and not any other tech training company out there. First, we like the fact that Cognitir has already trained thousands of CFA charter holders at most of the world's largest CFA societies, and many of the students from top business schools, including MIT Sloan, Wharton, UCLA, and London Business School. We also like the fact that the courses are hands-on and specifically designed for finance, and that they cover the whole training spectrum, from beginners to experts. In a nutshell, we value their boutique and pragmatic approach, and we are pretty sure that you will also appreciate this. And without further ado, David, the floor is yours.
Thank you so much, Alejandro, and also Marie. First of all, this has been great, a great experience setting up this event. I think you two have done an amazing job in launching our partnership and also setting up this event. So thank you so much for this opportunity to give this presentation today. Really, what I want to do in the next couple of minutes is to just give you a short glimpse of what is actually going on in the world of AI, and really try to avoid the best I can any sort of hype or buzzwords or jargon, and provide a down-to-earth overview. And this is especially important because, unfortunately, the world of AI is full of hype and buzzwords. And it is especially important to navigate this as everyone talks about it, but very few people know what's actually going on. And an interesting aspect of this is that the definition of AI is also changing. So what we consider to be AI 20 years ago, that is not really what we consider AI to be today. And so before we continue, wanted to give a brief introduction of myself. Alejandro mentioned a few aspects already. I founded Cognitir in 2015 together with my partner Neil Kumar, who is a CFA charter holder himself, to equip finance and business professionals with in-demand technology skills so that you can make better decisions in a technological world. And as Alejandro mentioned, we work with most major CFA societies around the world, top business schools, and a variety of companies. In addition to that, I founded a new company recently called Lakera to help other companies build better and safer machine learning from a more technical perspective. Previously, I had a chance to work across all major industries to see what it really means to build good software. After working in banking and healthcare, I learned what it means to build really safe software at a company called Daedalian here in Zurich. I worked among a great group of engineers there and scientists to develop the first fully autonomous autopilot for airplanes. And to put that into perspective, we need to build software that can fly around planet Earth millions and millions of times without failing once. And in line with that, for about the last 2 years, we pioneered a whole lot of safety standards together with the European Union aviation safety agency to really set the foundations for how you would create such AI systems that need to live up to these high standards. And as we will see in this presentation, this is absolutely relevant beyond aviation, as some of these regulatory beginnings are also starting to trickle down to other industries. But before we get started and look at what this all means in detail, we wanted to warm up a bit, and we wanted to understand a bit better what your motivation is for signing up to this event and how you would describe your relationship with AI. So Marie, if you could bring up the first poll question, that would be absolutely fantastic. So what is your relationship with AI? How would you describe that? There are 2, 4, 5 options here. I notice people talking about AI, but I don't really know more. I'm unsure about AI's challenges and limitations. And maybe also I'm unsure about AI's opportunities. I know what AI can do in theory, but I've not used it in practice. I actively use AI, and I have processes in place to ensure that my company's AI is robust and compliant with regulations. So take a moment in answering that, and I believe Marie will show us the results once we have the submissions.
Yep, just a few more seconds.
Very cool. So this is the sort of picture that we see around the world. Let's actually look at what some of the practical aspects are around building AI. We will get to this point later on in the presentation. So you've probably seen this a lot of times. AI is this magic tool to automate human intelligence and package it into complex systems. Alejandro was already referring to quite a lot of words and terms that are used interchangeably with artificial intelligence. We have machine learning, the idea to use data as experience and learn a model from it. There are a whole lot of things going on there. But then we also come across data science, which is a very versatile field to extract knowledge from data. So they all somehow belong together. And what we realize is there's a lot of data science that has nothing to do with machine learning, and a lot of machine learning that has nothing to do with AI. Yet, like I said, they're all somewhat overlapping. The interesting aspect is that in practice, it looks a lot more like this. In reality, to build real-world, safe, and compliant artificial intelligence, what we call machine learning is really only a small part of the equation, and I will allude to that a bit later on during the presentation. Given that these technologies are all data-driven, so we learn from data and they are fed with data during operation when they are in production, we really spend a lot of time working with data, preparing and analyzing our data sets, and look at things such as avoiding bias and guarantee that the data we use is actually representative of our use case, making data science a pretty fundamental part of building artificially intelligent systems. Now let's look at some of these use cases, and I'm sure most of you have heard of many of these applications, so I just wanted to share 2 brief examples of maybe applications that are a bit more unheard of. So ESG and responsible investing are obviously very dominant topics in the financial world these days. And so investors are really working on natural language processing solutions, or NLP for short, to screen and optimize and build thematic sustainable funds and understand the effects that maybe news information or company activities have on these ESG requirements. And then there's this whole talk around alternative data. I recently talked to an investment professional who is looking to use open source project activities, and more specifically, things you can track on GitHub that hosts all these open source projects, to identify new investment opportunities. So as developers are suddenly getting a lot of attention on GitHub with their open source projects, there's a lot of activity in the code happening. investors are really tracking that to really drive some of their investment opportunities for startups, but also other projects that are relevant to their investment criteria. And if we go back to the slide, I mean, from algorithmic trading to anti-money laundering to even interacting with customers, the one interesting thing that unites them all is that they come with different potential for impact. And as a result of that, they also have varying regulatory requirements or compliance aspects. And really what it comes down to is varying levels of safety that is required for these systems. So ultimately, a big topic that we need to think about is governance. So if we look at banks and some of the literature that is coming out of banks and the challenges that they are facing, key AI governance risks really include things like data quality and privacy. So GDPR is obviously a big topic for everyone. Model validation. So development teams need to convince themselves that their models work. And then there's also this aspect around model reliability and interpretability to convince others that the models work as expected. So these may be customers, these may be regulatory authorities, and so on. So what I wanted to do for the next few minutes is to take a look at what all of that means in the context of how we build machine learning applications today. And we will keep this at a very high level to not get lost in technical details. What we currently do is we start with requirements gathering, and this may seem something relatively obvious and trivial, but really what's involved here is understanding and defining the problem that we want to solve. And honestly speaking, this is also one of the hardest parts of the entire pipeline. It requires stakeholders to come together and define the requirements. So what do we want the machine learning system to do? And it also needs to these requirements need to be translated so that tech teams or data science teams understand what these requirements are and understand the metrics that they are optimizing for so that they can implement everything efficiently and also understand what their respective goals are. And then something that we need to make sure is that all subsequent stages of this workflow, which actually sounds easier than done, is we need to hold all of these stages accountable to these requirements that we defined initially. So within banks and financial institutions, this is where you often see business individuals and product managers work together with technical development teams. And really you see a lot of confusion around what should be done and who should do what. Once we are somewhat aware of the requirements, we need to collect some data. And the common theme speaking to development teams, product teams across financial institutions and banks is really that the data mostly already exists, or at least in many situations. But they may not be in the right format, and they may also be spread over various data sources. And this is especially tricky in the presence of legacy systems. It may be extremely challenging to get the data together. And so this block is where we really spend significant time in this workflow. Is even when the data is gathered, it is often not clear which aspects of the data are useful. You may have heard of things like feature engineering, really deciding which parts of the data are relevant to our machine learning systems. So if you, for example, think of a fraud detection system, automatically using machine learning to automatically flag fraudulent transactions, you may require customer demographics data from one source in one system, and then you have your live transactional data coming from another source. And there's a challenge in sort of putting that together, but then also figuring out which parts of the data that is often complex and high dimensional actually help us accurately predict predict fraud. The learning, or more in data science language, the modeling part, that is actually relatively easy, and good processes are in place. Depending on what sort of data we are working with and the complexity of the model, this may take a lot of compute time. So the computer or the systems may actually spend a lot of time in this training phase, but we as humans have good processes in place, and we don't spend too much thinking time usually on this. Things get a bit more fuzzy again once we want to understand if the model that we've just trained, or the model that we've just had from the learning phase, performs adequately. So coming back to the fraud detection example, here we really want to determine what the fraudulent amount is that we are able to prevent from happening with this particular model. And we're obviously looking to maximize this quality. So metrics, in other words, are not easy to get right. And we really need to make sure that the metrics reflect the requirements that we defined initially. We need to hold this step accountable to this very first part. And we need to make sure that the stakeholder interests are also reflected in our metrics. And then there are a lot of problem-specific challenges. So depending on the type of the model, you may require certain types of metrics and imbalanced data sets. Again, fraud detection, most transactions are probably not fraudulent. So it's sort of the prime example where you really want to have different cost associations with your decisions and mistakes that you make, imbalanced data sets. They need to be taken into account when you design metrics. And it's important to get this right, because this is also where you can lay the groundwork to shine later on when you try to convince other people that your model is having a positive impact. Again, this is maybe one of the key metrics that you're looking to present to other people. You know, we are able to prevent X millions from automatically detecting fraudulent transactions across our systems. So really taking the time to get this right is important, and it really is the point where you want to make sure that your model satisfies your requirements. And then ultimately you put your model into production, and this is often done by different teams. So the typical picture that we see is that data science teams would hand off the model to more sort of a software engineering team that would then put this into production. At the same time, you still need to make sure that the model works as expected. And the product of this workflow is really what we call the machine learning code. The machine learning code contains the model which encodes the logic that we initially set out to create and that we are now putting into production. It ideally should be a reflection of the requirements that we defined across multiple teams with all the stakeholders initially. So with that in mind, we had a second interesting question, a second interesting poll that we wanted to run by everyone in this session today. Marie, if you could bring that up, that'd be awesome. Great. So where do you think, looking at the workflow that we've just gone through, development teams actually spend most of their time? So is it at the beginning, the requirements gathering, the data collection, the learning? I guess I gave a sort of hint there, or the evaluation, or finally the deployment. So let's give it maybe a few more seconds and take it from there.
Just a few more seconds to answer.
Great. I think this is a common picture that we see. So, and it's probably a byproduct of how I also presented this workflow. Now, at the same time, yes, the data collection is very time intensive. I mentioned the legacy systems, especially if you talk to data scientists in financial institutions, they have to cram through various sources, and it's often not clear what data is relevant, and also making sure that data is historically correct, so that you're using, looking sort of into the time dimension, that the data you're using for your model is correct and representative, especially when we think of, interesting times with the current health situation in the world, that you have all of this considered on a time dimension. This looks great. The picture in practice may be reflected like this, but what's important to realize is that this is really, while we spent a lot of time on data collection, the truth is that the development process is not a one-way street, and it has a lot of feedback cycles and often requires many iterations and input from various teams to really get things right. And even after you've gone through this process, what we often find with real-world AI systems, especially those that can have significant impact, think of automated trading or credit scoring, they come with very little real-world guarantees after you've gone through this process. And you have no real-world guarantees that the system will actually do what it's supposed to do. So we are operating systems in production today following this workflow where the situation really looks more like this or this. The truth is, AI systems have already messed up and lost millions of euros or confused people's credit scorings. And what we are starting to see is that the development workflow for real-world safety-critical AI really needs to be a bit different. And coming back to this slide setting, a whole lot of additional activities are required to obtain the trust that is required to operate mission-critical, safety-critical, or generally just safe machine learning, especially when that has an impact on a company's reputation or financial performance or society at scale. And I'm not going to go into any of these terms or topics here in detail. It is really just an illustration of the sheer amount of things that need to be done to build robust and safe machine learning. And we haven't even spoken about an additional complexity of all of this, which is, imagine doing all of this in the context of quickly evolving regulatory requirements. So what we are seeing here is the result of the European Union's work from 2019, which presents the ethics guidelines for trustworthy AI and their 7 pillars for what they consider to be important aspects of building trustworthy AI or achieve AI trustworthiness. This is really a term that you hear in a lot of literature, in many discussions, and really sort of is really the North Star for what we are setting out when we are building safe and robust AI. So while I disagree with some of the fundamental approaches to defining these guidelines at this level, this is extremely important work. It defines how industries implement their own AI strategies, including finance, and it will ultimately affect all companies in all industries. So some of the work that we've done with the European Union Aviation Safety Agency is a direct result of the work at this level. And there is similar work happening in finance. I noticed, for example, the French Monetary Authority, the AMF, is mentioning these guidelines. And specifically to this audience, I'm also sure that this will be an important topic for CFA candidates and members very soon. There are a lot of working groups and a lot of work is done how we can reach these regulatory standards and these regulatory requirements with the AI that we are implementing. When we look at all of this, we realize that building AI has really all the operational challenges of traditional software, which we know how to make very safe, plus many of the problems that are specific to machine learning and AI that we still need to do a lot of work to make this safe. And the organizational effort to consider all elements of building safe real-world AI is extremely high. And it needs to be executed efficiently and with some of the aspects that we mentioned, safety compliance, data privacy, validation, explainability from the start. So when we execute the machine learning workflow, the development workflow, we need to start with the requirements and phrase them in such a way that we have all of these aspects in mind from the start. And if you don't do that, you end up in what we call the prototyping trap. And we already see a lot of projects fail or never see the light of production. And so this may obviously sound very daunting, and it does, because there's really, in the future, a severe risk that these requirements are slowing down innovation across industries, including finance. And we have a good chance to rethink how we think about AI and machine learning in industry right now. And there's really a chance for those that embrace the challenges and are looking to translate them now. Education is key, especially for people that are maybe not developing AI themselves, but need to be in a position to assess the opportunities and risks and understand what can be done and what cannot be done. So my main recommendation is to expose yourself to the basics of these technologies and really understand what are the risky elements, what are the opportunities, and how do we communicate efficiently in between teams. And with that, before we allude to our work at Cognitir, we have one more question, which I would love for Marie to bring up and present to the audience. So we wanted to get a better understanding of what is important to you and what is it that you would like to learn about AI. Do you want to better participate in business meetings? We talked about the opportunities, risks, and challenges. There's an element of communicating with technical teams, estimating project timelines and meet project deadlines, assess compliance risks, or develop AI yourself. I think all of these are interesting angles. Where do you see potential to learn more about AI? Oh, very cool. So assessing the opportunities, risks, and challenges, that sounds great. I'll talk about this in a second. Developing AI myself, that is surprising. Seems like we have a lot of practitioners in the audience and people that are pretty close to the technology itself. I would love to hear more, maybe in the Q&A after. What are you looking to develop there? Assessing the risks and the challenges, that is something that we are looking to sort of, looking to provide you with the skills that are required to do exactly that with Cognitir. As we mentioned at the beginning of this session, we work with the largest CFA societies across the world. And the topics that we offer to people range from data science and machine learning to product management, how you manage sophisticated tech products, including some of the workflows that we've discussed here. And not really, offering technical deep dives, but really just what matters to a finance audience. So the people that leave our courses, they generally leave with the ability to make better decisions when it comes to technology projects and technology investments and so on. And they also can better participate in meetings which really look at the risks and opportunities on all levels that we discussed here, and better communicate with technical teams. What you ultimately get, and this is something that is so important, I just want to stress again, is this gray area, as I call it, between technical teams and people in business, people in finance. This gray area is really where we can make a lot of magic happen. It starts with the understanding of the requirements and translating them to technical requirements from a product level to a technical level. This is where you can really excel when you understand both the foundations of finance and the foundations of AI and machine learning. And we've seen that this also really opens up completely novel career paths from data analysts to chief information officers or chief data officers. The courses are extremely short and to the point. So again, just giving you really what you need. And I just realized the top left photo was actually taken in France. This must have been around 2016, 2017. I was at HEC, close to Paris, giving our introduction to data science workshop. And the courses are practical, hands-on. You don't need any prerequisites. We literally take you from zero. And the one thing I have to say is they don't focus on making you technical experts, but really developing you into competent and pragmatic leaders in a technical finance world. So to that end, we are working with 3 different formats. One is the live format, where we give in-person workshops. That is obviously less relevant in the current health situation. So a lot of our work has shifted towards online offerings. We've successfully set up virtual classrooms for people to join us in webinars. And also we have a self-paced online platform that allows you to study at your own time. With that, I would like to offer the floor or open the floor for questions. I've left some contact information here, and I would very much like to thank you for your attention. We could probably talk about this all evening, but we only have 1 hour for the entire event. So if you have any questions, let us know.